Hello students, today we will be seeing some NCERT exercise 2.1. Okay, we will be seeing what solution of NCERT exercise 2.1. Okay, let's see our first question. Our first question is sine inverse minus 1 by 2. What we need to find? We need to find this value. What we know that sine inverse is from where to where? Minus 1 to where? The closed interval minus pi by 2 to pi by 2. Okay, so we need to find this is equals to what, and this what must belongs to in this interval. Okay, so how we are going to solve it? Quite easy. Always start with sine inverse minus 1 by 2 is equals to y, something like this. Always start with this. Okay, now what you will do first, you will write this, then you will write this. Okay, like this. Now what you will do, you have is sine y is equals to minus 1 by 2. Just multiply with minus sign to both side. What you will get is half is equals to sine minus half is equals to minus sine y. Okay, where half is what? You know that this is equals to sine pi by 6. Sine pi by 6. Now minus y. Okay, now what? Now it is what we know that sine is what? Sine is odd function. So this means that sine pi by 6 is equals to sine minus y, because sine is odd function. Odd functions are those functions when f of minus x is equals to minus of fx. Okay, and in sine function this happens, so I can easily rewrite this as this. So from this what I can say is minus 6 is equals to pi by 6, and from this what I can say is y is equals to minus pi by 6. And then now is this enough? So what we still have to do is still have to confirm that y must belongs to what? Minus pi by 2 to pi by 2. Let's check. So minus pi by 6, indeed it is less than this. Okay, what about, is it greater than minus pi by 2? Let's see. So we know what we know. We know minus 6 pi is less than minus 2 pi. Yes, just multiply with 1 by 2 to both side. What you will get this, the inequality remains the same. Okay, now just multiply with 1 by 6 also, you will get this. So as you can see that minus pi by 2 is less than minus pi by 6. So indeed, so now we can say that the principal value of sine inverse minus pi by 2 is what? Minus pi by 6. To be a principal value, the value must belongs to this interval in the case of sine inverse function. Okay, I hope that it is now clear to you. Let's move to next question. So the question remains the same. Find the principal value for this. If you recall that the cos inverse is from where to where? Minus 1 to 1 to closed interval 0 to pi. So if you say that it is equals to y, then your y must belongs to closed interval 0 to pi. Okay, so first of all you find y, then verify that it belongs to this or not. If it belongs to this interval, then it is your principal value. If not, then we will do something else. Okay, so let's see the solution. So first of all, what you will do, just write the expression equals to y, then write cos y is equals to root 3 by 2. Then what this equals to, if you recall, this is the value of cos pi by 6. Yes, cos pi by 6. Okay, cos pi by 6. Okay, now what? Now from this we can say y is equals to what? Pi by 6. Okay, now verify that pi by 6 is belongs to this interval. Is pi by 6 is greater than equal to 0 and less than equal to pi? Yes, it is. Is this happens? Yes, it is true. So we can say that this y is equals to pi by 6 are principal value for this. Okay, I hope that you are finding these question very easy. Let's move to next. Now find the principal value for this. Okay, first of all, recall the domain and the range for it. If you recall cosec, what is our cosec function? If you recall cosec, we start with the sine function. So the cosec function will be what? Like this. Yes, if you recall like this. So minus pi by 2 here is what? So sine, if you recall, sine function looks like this. Whenever sine is 0, we plot the asymptote over there, and then what? You plot this. So 1 upon sine x, if you recall. So this will be what? This will be pi, this will be 0, and this will be minus pi. So the cosec is from where to where? If you recall, cosec is from where to where? From this to this. This means minus pi by 2 to pi by 2 closed interval, but except 0. We exclude 0 because of this, because this cosec function is not defined there. To where, if you recall, what? The all real number except open interval minus 1 to 1. Okay, so now what you will do? It is quite easy. Now your cosec inverse must be from R except minus 1 to 1 open interval, and the range is what? Minus pi by 2 to pi by 2 closed interval except this point. So if this is equals to y, then what? Y must belongs to where? Y must belongs to where? In this interval. Yes, yes, yes. So y must belongs to closed interval pi by 2 minus pi by 2 to pi by 2 except 0. So now what you will do? Just start with the same as we did in previous questions. So write it equals to y, then rewrite it as like this. So cosec y is equals to 2. Okay, now we know what 2 is equals to what? Cosec pi by 6. Okay, so from this what I can say, pi can be y value can be equals to pi by 6. Okay, now verify that y belongs to minus pi by 2 to pi by 2 except 0. Verify y belongs to or y does not belongs to, which happens. Okay, okay, if this happens then we are good to go. If this happens then we are not good to go. So in this case you will see that y is less than pi by 2 but greater than minus pi by 2. So this means what? That our principal value for this is what? Pi by 6. Okay, I hope that you are getting the steps. Let's move to next question. In next question, find out the principal value for this. Okay, what is our domain and codomain, or the range for this inverse function? We know, if you recall, this is the tan inverse graph, and this is minus pi by 2, this asymptote is pi by 2, and the domain is whole R. So this tan inverse function is defined from the set of all real numbers to open interval minus pi by 2 to pi by 2. This means, what this means? This means that if this is equals to y, then y must belongs to the open interval pi by 2 to pi by 2, or the principal value branch. Okay, so let's start. So this equals to what? Y. Okay, so this equals to y. Then what we can rewrite it as? Tan y is equals to minus root 3. Okay, now what we know? What we know is that root 3 is equals to tan pi by 3, and also we also know that tan is what? Odd function. And odd function means if f of minus x is equals to minus of fx for every x in the domain of the function f. So this means is odd. Okay, so from this, what I can rewrite it as? Tan minus pi by 3. Okay, from this, what I can say is y is equals to minus pi by 3. Now verify is this value y belongs to the principal value branch. Let's see. If you recall, what is our principal value branch? It is minus pi by 2 to pi by 2, open interval minus pi by 2 to pi by 2. As you can see, what? That minus pi by 3 is less than pi by 2. Okay, and we know that minus 3 pi is less than minus 2 pi. Okay, just divide by 3 to both side, what you will get this, and now divide by 2 both side, what you will get is this. From this, what you can say, that minus pi by 3 is greater than minus pi by 2. So from this, what I can say is that the value of y, which is minus pi by 3, is less than pi by 2 but greater than minus pi by 2. So from this, what I can say, that indeed y belongs to the principal value branch. So the principal value of tan inverse root 3 is what? Minus pi by 3. Okay, let's move to next question. Now we need to find the principal value of cos inverse minus 1 by 2. Okay, if you recall, what is our this function domain and codomains, as well as what its is range. Okay, so the cos inverse function is defined from where to where? Minus 1 to a closed interval minus 1 to 1, and the range set is closed interval 0 to pi. Okay, so if cos inverse minus 1 by 2 belongs is equals to y, then this y must belongs to closed interval 0 to pi. Okay, now how we are going to find the principal value? It is quite easy. So first write this cos inverse minus 1 by 2 equals to y, then rewrite it as like this: cos y is equals to minus 1 by 2. Then what we know? We know cos y is equals to minus 1 by 2, and we know 1 by 2 is what? Cos pi by 3. Okay, now what? Now you can see, what you can see, that this is equals to what? Cos pi minus pi by 3. Cos pi minus pi by 3. So whenever cos pi minus theta, cos pi minus theta, if you see like this, then this will always be equals to what? Minus cos theta. Minus cos theta. Why? Because this pi minus theta will lie in which quadrant? Second quadrant, and in second quadrant cos is positive or negative? Cos is, in second quadrant, cos is negative. So negative. So this means cos pi minus pi by 3 will equals to be minus of cos pi by 3. That's what it is written over here. Okay. So what we can say that it is equals to what? Cos pi minus pi by 3, and from here what I can rewrite it as 2 pi by 3. And from this what I can say? I can say that y is equals to what? Y can be equals to 2 pi by 3. Now verify that is it belongs to the closed interval 0 to pi? Yes, indeed. So from this what I can say, therefore the principal value of cos inverse minus 1 by 2 is 2 pi by 3. Okay, let's move to the next question. Now question 6. The question remains the same. Find the principal value of tan inverse minus 1. Okay, so first of all, if you recall the tan inverse function domain and the range, what is it? The domain is what? If you recall from the diagram or the graph of the tan inverse, you can see the domain is the whole real number sets and the range is open interval minus pi by 2 to pi by 2. Okay, minus pi by 2 to pi by 2 open interval. So this means if you are going to write tan inverse of minus 1 equals to y, then this y must belongs to open interval minus pi by 2 to pi by 2. Okay. Now what? Now let's solve it. So you begin with this. Tan inverse of minus 1 is equals to y. Then you rewrite it as tan y is equals to minus 1. What is 1? The value of 1, when you will get tan 1. So it will be at pi by 4. So now minus 1 is equals to minus of tan pi by 4. Now what? Now as we know, tan is either even or odd. What is it? It is odd. Yes, it is odd, because odd function shows or exhibit this property, which is f of minus x is equals to minus of fx for every x in the domain of f. Okay. Okay. So from this what I can say is that minus tan pi by 4 is equals to tan minus pi by 4, and from this what I can conclude is that y is equals to minus pi by 4. Now it's time to verify that does this y belongs to the principal value branch, and the principal value branch for tan inverse function is what? Open interval minus pi by 2 to pi by 2. Does minus pi by 4 belongs to this open interval? Yes, as you can easily see that minus pi by 4 is less than pi by 2. Okay. Does this is strictly greater than minus pi by 2? Yes. Why? Because we know minus 2 pi is strictly greater than minus 4 pi. If you divide by 2 both side, what you will get this, and now if you divide by 4 both side, you will get this. So this shows that minus pi by 4 is strictly greater than minus pi by 2. So from this you can conclude is that this value of y, which is minus pi by 4, lying in the principal value branch. This means that the principal value of tan inverse of minus 1 is what? Minus pi by 4. Okay. Now let's move to next question. The sec inverse 2 root 3. So we have to find out the principal value of sec inverse 2 root 3. Okay. For sec inverse, if you recall from the graph, so first of all the sec x graph, sec-x graph looks like what? If you recall, the sec-x graph looks like this. Okay. And we defined from where to where in order to find its inverse. We defined it from 0 to closed interval 0 to where? So 0 to pi, but excluding pi by 2. Okay, excluding pi by 2 because at pi by 2 cos x becomes 0. Okay, and from where to where? At all real numbers except open interval -1 to 1. Okay, this means my sec inverse function will be from where to where? All real numbers except -1 to 1 interval to closed interval 0 to pi except pi by 2 point. Okay, so if this is equals to y, then y must belongs to this set. Yes, so let's find out. So sec inverse of 2 root 3 is equals to y, then rewrite it as sec of y is equals to 2 root 3, and we know this is equals to what? Sec of pi by 6. Okay, now what we can say that y is equals to pi by 6. Now verify that y value of y belongs to the interval, belongs to the principal value branch, does it? Let's verify that. So my principal value branch is closed interval 0 to pi, except we are excluding the point pi by 2. Okay, now indeed a pi by 6 is less than pi, and indeed pi by 6 is greater than 0. So from this what I can say that we can easily conclude that y belongs to the closed interval 0 to pi except y is not equals to the point pi by 2. So therefore the principal value of sec inverse of 2 root 3 is what? Pi by 6. Okay, I hope that you are getting this solution. So let's do the 8th question. So find out the principal value for cot inverse of root 3. So the principal value branch for cot inverse is what? If you can recall, it is open interval 0 to pi. Okay, then let's start with this thing. Cot inverse root 3 is equals to y, then rewrite it as cot of y is equals to root 3, and at what value cot gives the output of root 3 at when you give the input of pi by 6, your output will be root 3. So cot pi by 6, the output will be what? Root 3. So from this what you can say is that y is equals to what? Pi by 6, and this pi by 6 indeed belongs to open interval 0 to pi, and from this what I can say that the principal value of cot inverse of root 3 is pi by 6. Okay, now let's move to next question. Question 9. Question 9 says what it says. Find the principal value of cos inverse of -1 by 2. If you recall, the cos inverse function is defined from -1 to 1, closed interval -1 to 1, to the range is what? Closed interval 0 to pi. So if this is equals to y, then this y must belongs to the closed interval 0 to pi. Okay, now what? Now let's solve it. So first of all, what we will do, just rewrite it as like this. Cos inverse of -1 by root 2 is equals to what? Y, and then rewrite it again as this. Cos y is equals to minus of 1 by root 2. We know that 1 by root 2 value is when cos pi by 4. The input is pi by 4. Okay, now what? Now as you can see that it is minus cos pi by 4. Okay, minus cos pi by 4. So this means what? That my cos will be either in the second quadrant or in the third quadrant. So if it is in the second quadrant, then what I can rewrite it as cos of minus pi by 4. Okay, so because in third quadrant we know this is whole as pi, and if we are still in here, then we can do what? Pi minus theta. So pi minus theta. So cos pi minus theta is equals to minus of cos theta. Always remember this. Okay, so from this what I can say that minus of cos pi by 4 is equals to cos pi minus pi by 4, and after simplifying this, what you will get is 3 pi by 4, and now I can say that y can be my 3 pi by 4, and from this we need to verify that is this value of y belongs to the principal value branch. So yes, indeed 3 pi by 4 is greater than 0. Can so, and we know what we know, that 3 pi is strictly less than 4 pi. Yes, multiply both the side with 1 by 4. Okay, 1 by 4 and 1 by 4, what you will get? You will get that 3 pi by 4 is less than pi. So this means, so what this means is that the value of y, which is 3 pi by 4, is belongs to the interval, closed interval 0 to pi. So this means the principal value of cos inverse of minus 1 by root 3 is what? 3 pi by 4. So that's it for today. We will meet again soon. So thank you for now.